So, practice for Mod 11 test. Here we go. Number 1 says -5x to the 3/4 power. So, here's my question. What is getting the exponent? Actually, what are the instructions, first of all? Which expressions are equivalent to expression or expressions? What does that mean?
There may be more than one.
That little s in parentheses means there might be more than one, which means you can't just find the answer and then skip the rest. You have to check them all. Okay? Same thing with number 2. It's a teacher's sneaky way of making 4 problems into 1. You're welcome. Okay, so let's see. What do I know about this? I know that because this -5 is not in parentheses, the -5 is not getting the exponent. Only the x is getting the exponent. So the -5 is going to be outside the radical. The x is going to be inside. What is the index of the radical? 4. And then the exponent would be a 3. Or you could write the 3 like that. As long as it's not applying to the 5, you should be good to go. So, if I look at my options on the sheet, A, B, C, and D, let's look at these. Letter A, does that follow one of my possible answers? No, why not? They switched the index and the exponent, didn't they? So A cannot be a possible answer. What about B? The 5 is in the radical, can't be an answer. C? Same thing, 5 is in the radical. D? That does match one of my answers. D is the only one that is reasonable for that problem. So? Okay. Number 2, you're going to kick yourself once you see what you're supposed to do with the negative exponent. Because you're going to be like, oh, I knew that, but it just didn't come to me. What do you do with a negative exponent?
Make it a fraction.
You make it into a fraction. When you have a negative exponent, you have to bump it to the bottom.
Oh man, I didn't do that one.
To make, I told you, you're gonna be like, dang it.
Well, the answer was a fraction.
So if I look at options A, B, C, and D here, A, B, C, and D, I can already eliminate A and B because why? They're not fractions. Negative exponent has to make a fraction. Those two aren't fractions, they get eliminated. So I'm down to C and D. So let's see. Both of those are in radical form. So if I were to write this in radical form, that would be 1 over the cube root of 27m all squared. Yes? That matches with option D, so I know D is good. Let's check C. Okay. Let me think about this in a slightly different way. I'm going to go back to here. I could think of this also as 27 to the 2/3 and m to the 2/3, right? Because I can distribute that exponent to both of those.
Yeah.
What is 27 to the 2/3? I can go to my calculator, or I could remember that it's the cube root of 27, which is 3, squared is 9. So 27 to the 2/3 power, if I check it on my calculator, should be 9. Yep. So that gives me 1 over 9m to the 2/3. Now do you notice the 9 is not in parentheses like the 27 was? Because I already applied the exponent. So that means if I were to write this in exponent form, or in radical form, it's only the m that would be under. Does that match C?
Yes.
Yes, so C is also a valid answer. So? Okay. Number 3. Simplify. Now, I did one like this on the board with you the other day. Do you remember? I could either recognize the cube root of 64 as what? 4. Or if I don't recognize that right off the bat, I can always draw a tree. And what would I be looking for? How many of a kind? 3 of a kind. Why 3 of a kind? That's the index, right? Okay, so that's my tree for 64. Yes, I tend to always just divide by 2 because then it keeps my 2's all grouped together, so it's easy to find my groups of 2 or 3 or 4, whatever I need. So I need groups of 3, so there's a group of 3, which means I have a 2 outside. Here's another group of 3, which means I have another 2 outside. So what does that mean? I have 4 total outside and nothing left from that 64 inside. Again, if you recognize that this is asking for the cube root of 64, you can skip that and just jump straight to the fact that it's 4. All right, the A's. If I have 3 A's and I'm looking for a group of 3, I can take one group of 3 out, and there's no A's left inside. B's, I'm hoping that you're not going to make me write out all 27 B's to figure out how many groups of 3 there are. There are 9 groups of 3 with nobody left over, right? So 9 groups of 3 would be B to the 9th, and nobody's left inside the radical, so that's my answer. So on that guy? Okay. Moving on to number 4, same exact type of problem. I'm going to ignore the 2401 first, and I'm going to start off with the F and the G because I think they're going to be easy. If I have F to the 8th, what's the 4th root of F to the 8th?
2.
With nobody left home, right? And the 4th root of G to the 4th? With nobody left home, right? Because all 4 come out. Now, I'm going to see if my calculator can show me the 4th root of 2401, and if that's a nice number, I'm good to go, right? How do I do a 4th root on my calculator? Do you remember how to do a 3rd root? There's this X radical button, so if you hit that X radical button, oops, mine's going to freak out. It does answer right there because it wants the index typed in before you press that. So if I want a 4th root, I actually have to type in 4 and then that, and that means it's going to calculate a 4th root. If I have a 5th root, I would change this to a 5. That's a 5th root. Okay, so you can do any root there. I need a 4th root of, what is it? 2401. And what does that give me? 7. Yay, it's a nice number. Which means what? There's nothing left inside the radical. So? Number 5. (243 to the 2/5). Okay. Well, I think that this is going to be easiest if I go to radical form. What would my index be? 5. And my exponent would be 2. Does anyone know what the 5th root of 243 is?
Not a good number.
Probably not off the top of your head. In other words, I'm trying to think what to the 5th power equals 243. Do you have any guesses? 3. Let's check it. Yep. Okay, you can use a reasonable guess there. So the 5th root of 243 is just 3. Then when you square it, the answer to that problem is 9. Can you start simpler up here? 243 to the 2/5 power. Sometimes your calculator might even just do the answer like that. Okay. I'm telling you, use the fraction button on your calculator. Especially when we get down to problems like 14, 15, 16, and 17, that fraction button is going to be a lifesaver. Okay? I did 243 to the, and then I just used my fraction button and typed in 2/5, and it calculates it for me. And this is why, because it's calculating the 5th root of 243, which is 3, and then squaring it.
If we're on a test, would you want us to show all that, or can we use it?
Well, you can use a calculator if you want to, because I will check to see if you know how to do this in numbers 7 and 8. Okay? All right, so let's look at number 6. Similar.
Oh, God.
So this is very similar to one that was on your quiz, yes?
I'm ready.
Okay?
Okay.
Now, if I have something like this, is that negative sign being squared, or is it just the x that's being squared? It's just the x. If that negative sign is being squared, it has to be in parentheses like that. Right? Just like if you had a 2x squared, that 2 is not being squared unless it's in parentheses with the x. So is that negative sign getting that exponent? No. So I really have negative 625 to the 3/2. And that negative sign is just going to stay out in the front the whole time. So if I have to rewrite this one in radical form, what is my index? 2. Do I write an index of 2? No. So I need to find the square root of 625, and then I need to cube it, right? And this negative sign is just hanging on there. What is the square root of 625? 625 is 25. Cubed?
A big number.
25 to the 3rd power is 15625. And because that negative sign just kind of held on the whole time, my answer is negative 15625. Okay? So now hopefully I've covered the questions you may have had on your quiz. Yeah? Okay? Negative exponents.
I got 2 points.
Negative exponents mean you got to make a fraction. Negative in front stays out front unless it's in parentheses. Yes?
How many points is that extra credit word?
1 or 2, I can't remember.
Both things work.
Don't worry, it's a 6-point quiz. It's not going to totally bomb your grade. Okay? Oh, ye of little faith. All right, can I move on to number 7?
Yeah.
Okay. Number 7. What do the instructions say for number 7? Write in radical form. So what's my index? 9. What's my exponent? I can either write my answer like this or like this. Either one of those is acceptable. You do not need to write both. Either one is acceptable. That's it. Number 8. Same instructions, write in radical form. What's different about number 8? Only the x is going to be in the radical. So I either have 3 times the 5th root of x squared, that's one possibility, or I have 3 times the 5th root of x squared. Either way. Just please, no matter which way you write it, make sure that there's nothing that looks like 3 to the 5th power. That I'm going to have an issue with. Do you see what I mean? Okay? So make sure that that index, you'll always see me trying to tuck it in there. This is an easy way to make it very clear that that's an index, not an exponent. Okay? Questions there? All right, let's get on to the fun ones.
It's alright.
Okay, so in this whole bit, it says, write each expression using rational exponents. So every answer in this section needs to be in exponent form, no radicals. Simplify numerical expressions when possible. I'll talk about that when we get to one. No 0 or negative exponents in your final answers. So I can't have an exponent of 0 and I can't have any negative exponents. But hopefully, since we did this, we know what to do with negative exponents. Right? Good answer. Okay, so this needs to be turned into exponent form. So what is going to happen? I'm going to have 3x to the what? 7/12. 12ths. Is that correct the way I have it?
Yes. No,
No, why not?
because the 3 is also getting.
The 3 and the x are getting all the same thing, so I need to put that in parentheses. Yes? Yes?
Yes.
Anybody? Okay, so 3x to the 7/12. Now, technically, that is a correct answer right there. However, I want to check this. What did I just do there?
Split it up.
I just distributed that exponent, didn't I? Why did I want to check it? Well, because it says simplify numerical expressions when possible. This 3 to the 7/12 is a numerical expression. So I just need to ask myself, can I take the 12th root of 3 and then raise it to the 7th power and get a nice number? Probably not, because the 12th root of 3 is probably not a nice number. It's not big, it's tiny, because it's what number to the 12th power equals 3? Something. It's not pretty, right? So I can't simplify it. So this is the simplest form, and because nothing could simplify there, I would accept this as an answer. However, if that could simplify, then this is not the simplest form. They're both right here because neither of them simplify when you split it up. Does that kind of make sense? Okay. Number 10, 4th root of 3m squared squared. All right, now look at this very carefully. You ready? This 3 is going to get this exponent, but it's not going to get this exponent. Because there's a difference between that and what I've got written there. So these two things apply to both the 3 and the m squared, but because this 3 is not in parentheses with the m, this squared is not applying to the 3. Do you get what I'm saying? Here, it would apply both. But because there's no parentheses in here, it doesn't. So here's how I'm going to simplify this. I'm going to take the 3m squared and put it in parentheses because both of these apply to it. So that gives it to the 2/4 power. What is 2/4? Isn't it 1/2? Yes? Now, if I distribute this one, because this would be like stopping here if I stopped here. Can I simplify anything? I get 3 to the 1/2 and then m to the what? 2 times 1/2? What is 2 times 1/2?
1.
1. So that's actually a more simplified form than this one. How did I get what? I get 3 to the 1/2, and then 2 times 1/2 is 1. And an exponent of 1 we don't write. So, why is this one okay in number 9 as an answer, but not okay here in number 10 as an answer? Because in this one, whether you distribute it or not, nothing simplifies. This one, if you distribute, something simplifies. So I do want you to simplify it if you can. Does that kind of make sense? If you always distribute it, you're good to go, because then you'll automatically simplify what you can. Okay? But I wouldn't take off points for this in a situation where it didn't simplify. So there? Okay. Number 11. 4th root of 16a parentheses to the 6. Do you see that there's parentheses in here and there wasn't up here? So that means I have 16a, and that 16 is going to get the 6th power also, right? To the what power? 6/4. What is 6/4 reduced to? 3/2. So if I distribute that and apply it to the 16 and to the a, I get 16 to the 3/2 and a to the 3/2. Now 8 to the 3 halves I can't do anything with, but I can do something with 16 to the 3 halves. Because 16 to the 3 halves is the square root of 16 cubed. What's the square root of 16? 4. Cubed is, so that simplifies to 64. And then I have the 8 to the 3 halves. And the 64 doesn't need to be in parentheses because I've already applied the exponent to it to get the 64. So when the instructions say simplify numerical expressions when possible, this is what I mean by simplifying numerical expressions. If you can actually calculate what that exponent is, do it. Okay? And again, you could do that in your calculator if you wanted to. You could do the 16 to the 3 halves power, and you do get 64 there. Okay? Questions there? All right, moving right along. 5th root of 32x cubed. All right. Does that 32 get the 3 exponent?
No.
Why not? It's not in parentheses. So what is the exponent on the 32 if it doesn't get the 3? It would just be a 1, right? No exponent means it's a 1, which means that I have 32 to the 1/5 power, but I have x to the 3/5 power. Does that make sense to you? Because the 32, its exponent is 1, that means it's got 1/5. X has a 3 exponent, so it's 3/5. Kind of funky. What is 32 to the 1/5 power? 2. And then I have x to the 3/5. Done. So?
You don't have to like multiply it.
Multiply what?
Like I would say that you only have to take like 3/5 and
Distribute it to both of them? Is that what you're thinking? Like this? No, because the 32 isn't in parentheses with the x. If it was 32x cubed, that cubed isn't going to the 32 in this case. So the 32 would just have an exponent of 1, which is why it's got a 1/5 right there. Okay? So you really got to pay attention to those parentheses. They make a big difference as to what you're doing here. Okay? And 13 is very similar. 4th root of 81x cubed cubed. Now this one is very similar to number 10 in a lot of ways. Because the 81, this exponent does apply to it, but this exponent does not. Do you see that? So only one of them does. So regardless, this whole thing right here, the 81x cubed, this and this apply to both of those. So I'm going to call this 81x cubed to the what? 3/4 power. And since it applies to both of those, I am going to distribute it to both of them. That gives me 81 to the 3/4, and then x to the what? 3 times 3/4? 3 times 3/4 is 2 1/4. I'm going to hit second and my fraction button again, and I get 9/4. So far, so good? Okay. 81 to the 3/4. Well, that's the 4th root of 81. Anyone know what the 4th root of 81 is? 3. Raised to the 3rd power, which is 27. If you don't know that off the top of your head, go ahead and plug in 81 to the 3/4 power, and it's 27. And that's my simplified answer. Questions there? All right, now we're into my favorite ones. All right, f to the 1/3 over f to the 7th all to the 1/8. Now, I like getting rid of any parentheses first. And if I have a whole fraction that has an exponent on it, then that exponent has to apply to everything on the top and everything on the bottom. Does that make sense? So, I'm going to have f to the, what's 1/3 times 1/8? 1/24 over f to the 7 times 1/8 would be 7/8. Now, a lot of people will stop here and think they're done. You can't stop here because you have two bases that match, which means you've got more rules that you can apply. Anytime you have two bases that match, you do the top exponent minus the bottom exponent. This is where your calculator's fraction button saves your butt. 1/24 minus 7/8 is -5/6. Now I can't leave my answer like that. Since it's a negative exponent, I do have to bump it to the bottom of a fraction to make that exponent positive, which means there's a 1 on the top, but that's my final answer with positive exponents. Do you see how I only have one base of f as opposed to two bases of f? But anytime you've got those matching bases, you have to do this with it. Okay? Questions on 14? Okay. Number 15. D cubed over d to the 1/2 all to the 1/10. Do you see that this problem is almost exactly the same as number 14? The letters just changed and the exponents have changed. But I'm still going to distribute to the top and to the bottom. So let's see. 3 times 1/10 would be 3/10. And what's 1/2 times 1/10? 1/20. Again, I have these matching bases, so I'm going to do d to the what? 3/10 minus 1/20. And you can do that on paper the long way, or you can go 3/10 minus 1/20, and I get d to the 1/4. It's a positive exponent, so I don't need to move it to the bottom of a fraction. If you do it the long way, you would recognize that this is 6/20 minus 1/20, which is 5/20, which reduces to your 1/4. That's the long way of subtracting those exponents. So? All right, I'd like to try and get through 16 and 17 here. And then I think we're in a good place. You ready? X to the 9/2 y to the 1/2 over x to the 18th y squared to the 1/4. Now, just to make sure we're all clear on this, this one only had one letter on the top and the bottom with the exponent outside. If what was inside here had two letters with it, then the exponent you distribute has to go to both of those letters, regardless of if they're on the top or the bottom. In other words, if I had something like xy over zw all to the 3rd power, that 3 has to go to the x, the y, the z, and the w, everywhere. Okay? All right. Let's see. On the top, don't need to do anything here. This problem is great, by the way. One of my favorites. Down on the bottom, I'm going to have to distribute that 1/4 to the 18 and to the 2. So what does that give me? What is 18 times 1/4? 18/4, and yes, that reduces. I'll get there in a minute. And then y to the 2 times 1/4 would be 2/4. So what do I have? X to the 9/2, y to the 1/2 over, what is 18 over 4 reduced to? 9/2. 2/4 reduces to 1/2. What's my answer? 1. Why? Because if I took my x's and I did that top minus bottom thing, I would end up with x to the 9/2 minus 9/2, which is 0. And with the y's, 1/2 minus 1/2 is 0. Well, x to the 0 is 1, y to the 0 is 1, and 1 times 1 is 1. So that's the reason why, when things cancel out, you're left with 1. So? All right, last one I want to do for you. A to the 1/4, b to the 1/2. If the bell rings, I am going to finish the problem, so if you'd like to see it, at least just stay listening. Third, b to the 5th. All right, I'm going to distribute this exponent on the top. There it is. So 1/4 times 8 would be 8/4. 8 times 1/2 would be 8/2. On the bottom, a to the 1/3 and b to the 5th. I'm going to simplify. 8 over 4 becomes 2, and 8 over 2 becomes 4. And now I have to do that top minus bottom thing that I did right here. I just have to do it both for the a's and the b's. So I would have a to the 2 minus 1/3 and b to the 4 minus 5. Well, 2 minus 1/3 is 5/3. And then 4 minus 5 is -1. My answer is almost okay. The a to the 5/3 can stay. But that b to the -1, he has to be bumped to the bottom. And my answer is okay like that because my bases are not the same, which means I've simplified everything I can. Okay? Happy studying!